Everybody. So, continuing with our discussion about systems of equations, guys. Now we're going to work on actually solving these systems. You have three different types, three different ways we're going to go into how to solve these things. The first one is going to be solving them by graphing, and that's our learning objective for today. I can solve these systems by graphing. Ties into exactly what we were doing before that quiz when we were graphing these different equations. Now all we're going to do is take all the equations in our systems, graph them on the same coordinate plane, find where they intersect, and find those solutions. Let's get into just a little review of what we're talking about, because if we don't know what a system of equations is, we can't really start here. System of equations is just a grouping of two or more equations. You find solutions to them by looking for points that satisfy all of the equations. This will be an ordered pair, an x comma y, a coordinate point in our graph. When graphing, there's going to be three different possibilities. Here's the first one. You have two lines that intersect each other. That point where they intersect, in this case 1 comma 2, is the solution to your system. The reason they intersect is because they are on both lines of that system. It's true for this positive slope line, and it's true for this negative slope line. So it's true. It's good for all equations in that system. It's a solution. Another one would be parallel lines. Parallel lines, they never intersect. If they never intersect, they never share the same x comma y, which means no solutions. Parallel lines, just to make sure we're clear, it's when you have the exact same slope, different y-intercepts. So we're moving at this top line up 2 and over 1, that's a slope of 2. Bottom line, you're moving up 2 over 1 again, same slope. Notice y-intercepts are different, which you could clearly tell from the graph. The lines are different. Same slope, different lines. They never intersect, no solution. The third type of graph we're going to see, coinciding lines. This is when the lines are exactly the same. Notice I've got red underneath blue. They're exactly the same line. They have the same slope. They have the same y-intercept. Solutions for this one is every single point. And if those lines continue forever and ever and ever, that's going to be an infinite amount of solutions. So you could plug any of these points on this line into your system, and it would be true for both of those equations. Notice with this line, you have the same slope, up 2 over 1, up 2 over 1. It's the same for both the blue and the red. Notice that y-intercept, that -1, is also the same. So coinciding lines, same lines, infinitely many solutions. Here's a little visual to help you remember the three different types we should see when graphing. We have intersecting lines, which is one solution. We have parallel lines, which is no solutions. We have coinciding lines, infinitely many solutions. Now, tying in some of the vocab we had in an earlier video, if you have different lines with one solution makes it consistent. Different lines make it independent. So this first one here is consistent and independent. Parallel lines, you have no solutions, that's inconsistent. And then they're different lines, that's also independent. So inconsistent, independent. The last one, the coinciding lines, you have infinitely many solutions. That's consistent, but since it's the same line, it's dependent. So three different types. Let's look at some examples with this stuff. Here's the first example. We have 2x plus y equals 4. We have x minus y equals 2. I want to graph this stuff. I don't like the form it's in right now. I want to try to convert it to slope-intercept form. No, actually, I'm not. I'm going to stick with standard form here. So since we have the x and the y together on both sides, standard form, let's find those x and y intercepts by plugging in zeros. If I plug in a 0 for the x, I'm left with y equals 4. Well, that's easy. Y must be 4. If I plug in a 0 for the y, I get 2x is equal to 4. Divide both sides by the 2. I get x is equal to 2. So there's my two intercepts. for the first equation, 0, comma 4, 2, comma 0. Now for the other one, same kind of thing. I plug in a 0 for the x. I get negative y is equal to 2. Divide both sides by negative 1. I get y equals negative 2. Plug in a 0 for the y. X minus 0 equals 2. That's x equals 2. So I have my other intercept point right there. Let's use these 4 points to make our 2 lines. I have 0, comma 4. So I'm at 0 for the x all the way up here at the 4. Then I'm at 2, comma 0. So I'm 2 for the x, 0 for the y. There's my 2 points. Connect them with a line. Good for that one. Second one, I have 0, comma negative 2. So 0 for the x, negative 2 for the y. 2, comma 0, 2 for the x, 0 for the y. Connect those with our line and see where they intersect. That intersection point is our one solution, 2, comma 0. Taking the equations, noticing what form they're in, if easy enough, graph in that form. If not easy enough, let's convert it to slope-intercept form and then graph away. This one was nice enough to graph in standard form, so we just found those intercepts, graphed, and saw they intersected at 2, 0, which is our solution. Let's take a look at another one. Oh my gosh, just kidding. Let's plug it in. So checking answers with systems of equations is pretty huge. We know it was 2, comma 0, so we're going to take the 2, plug it in for the x, plug the 0 in for the y. 2 times 2 is 4. 4 plus 0 is 4. That's true. Do it again for the second one. I have x minus y. That's 2, comma 0, so 2 minus 0. Is that 2? Of course it is. Since it's true for both equations, we double checked it. We know for sure 2, 0 is our answer. Let's do it again. Example number 2. Notice this top one is already in slope-intercept form. And now this bottom one is in standard form. But notice we would end up with 1/2. And I don't like that with intercepts. So we're going to convert this bottom one to slope-intercept form. Top one's already there. I got 2 equals 2x minus 3. Bottom one, though, we got to convert. We need that y all alone. So to get y alone, add the 2x to both sides. Gets rid of it here and makes it positive on the other side. So now I've got my 2 equations, both in slope-intercept form. Let's graph away. Using our slope and y-intercept, I have y equals 2x minus 3. Okay, well, my slope is that 2. Y-intercept is that negative 3. Looking at the other one, slope-intercept form, so my slope is 2. My y-intercept is 1. There might be some red alerts, some red flags showing up. Looking at those slopes, what does that tell us already? Let's graph to make sure. So I'm graphing this stuff. I had a +1 intercept, a +2 slope. So I go up 2 over 1, connect with that line. We're done. -3 intercept, +2 slope, up 2 over 1, up 2 over 1. Okay, connect with a line. Done. What do you notice about these lines? Parallel lines never intersect. That tells us right away no solution for this system. No solution. That red flag, that red alert we were mentioning, you saw slopes were exactly the same. If you recognize early, why graph them? You already know slopes are the same. You know why intercepts are different. You can tell they're going to be parallel lines right there. You can tell right away. No solution. Let's do some practice problems. Before that, summarizing real quick, 3 steps. Step number 1, graph. Step number 2, see where they intersect. Step number 3, check that solution. Okay, simple practice problems here, guys. I'm going to already give you the graph. All I want you to do is tell me, where do they intersect? You have these 2 lines here from this system, graphed. Where do they intersect? What is your solution? We should have 2, comma, -2. +2, comma, -2. Let's try it again. Same kind of thing. Not multiple choice this time, though. You actually have to tell me. Where do these intersect? What is this solution? 3, comma, -1. 3, comma, -1. Let's do another one. Same drill. Over 2, up 1. That's 2, comma, 1. Intersection point. Do I have another one? Yes, I do. What's this solution? -2, comma, -4. Guys, that's it for us today. Email me with any questions. Let me know what's going on. But all you're doing is just graphing, finding where they intersect, if they intersect, and then coming up with the solutions. Thanks so much, guys. We'll see you later.